20th century came about. Once they started increasing their protein intake, we started seeing chronic disease. So it has nothing to do with how much fat and how much carb they had. And that's because our body can easily convert fats into carbohydrates and carbohydrates into fats. It's so simple for metabolism to create energy from both macronutrients. But protein stands aside as a unique macronutrient that is different from all the others. It's different in that it contains an element, an atom, called nitrogen. And that's the main difference between protein and the other macronutrients. Protein contains nitrogen. Now the body has to do something with that nitrogen in order to convert protein into energy. And that nitrogen becomes the dirty residue of energy metabolism, just like having a car without catalytic converters, which are increasing the dirt and the pollution in the air. We want to burn clean because our cells depend on cleanliness. Our tissues do not want to be suffused with toxic metabolizing byproducts of energy production. So we suffer if we have too much nitrogen in our system. And that is why even the medical textbook of physiology that's most famously used in all medical schools, which is called the Guyton Textbook of Medical Physiology, even there, when they talk about the amount of protein that your body really needs, they talk about the obligatory use of protein, the amount that we actually lose every day in the stool. We're not supposed to lose much, if at all, in the urine. So we look in the stool to see how much protein are you losing every day. Your poop is the marker. And if you measure, you see that the average individual, the average man who weighs about 150 pounds, is going to lose anywhere between 25 grams and 35 grams of protein per day. That's the amount that you need to eat just to stay even. You don't need more than that, according to the textbook of physiology. But that textbook does not take into account indigenous people in some places who eat even less protein than that, and they're still doing okay. So what's the story with them? Why are some indigenous people in Africa able to sustain themselves of 15 or 20 grams of protein per day? The answer is recycling. If you eat less, you recycle more. You lose less. Because your body knows how to continuously conserve the amount of amino acids available to it for its various functions. So the more protein you eat, the more you lose. The body does not need to conserve as much. So even the 25 to 35 grams that is written in the medical book, even that is generous overall in quantity. But we want to be generous, don't we? We want to be as conservative as we can be, for the purpose of science, if nothing else. So when we look at all the activities of the body and when and where we need protein, let's say that we want to be slightly more large with ourselves and give ourselves 5 extra grams of protein. That would bring us to, let's say, 40 grams at the most. Remembering that this does not take into account how much we recycle. Now, if you are a typical American, which most of you are atypical Americans, you are here, but you have been influenced by a lot of typical Americans in your life. And they have always told you that protein is primary in our body. it's Proteus. Proteus means primary, extremely important, and that's based on old scientists who are no longer alive to undo the damage. They said, after investigating the body, the tissues, the cells, that a really important part of every cell in your body were proteins. And as a result, we assume that protein must be coming into our body in large amounts. But this is a little faulty, because on the contrary, if you can recycle extremely well, that's because the body needs to conserve what it has, and therefore you're not going to be ever necessarily in lack of such a nutrient. As long as you keep conserving it and building with it, and it stays in your body. For example, whenever you poop, as we said earlier, half of your poop by volume is the cells sloughing from your own gastrointestinal tract. And those cells contain a lot of protein which gets recycled. The body absorbs it. That's why we don't really miss much. Also, amino acids are very different from other nutrients like minerals, for example. Minerals, when they get into your body, they have a hard time being absorbed because they compete with each other for absorption. And the body does nothing to absorb them. Your body just sits there passively and hopes that through diffusion, some minerals will make it into your circulation. Unfortunately, today's foods are not as rich with minerals as they once were. So we are getting more and more deficient in minerals as a society. 80 to 90% of people are deficient in zinc, in magnesium, molybdenum, selenium, etc. All of those minerals, when they come in our body, they don't have an easy way because they compete for the receptors in our gastrointestinal lining. And we end up, if we take a lot of minerals in one supplement, and they are the typical minerals that occur in nature, in ionic forms, they will not be absorbed very well. Most of them will remain in your digestive system and cause diarrhea because of a process called osmosis. So the more minerals you have, for example, if you take mineral ascorbates or vitamin C powder, vitamin C powder contains a lot of minerals to buffer the acidic nature of it. Those minerals end up in your digestive system, and if you take a lot of that, you will have diarrhea. And if you have constipation, it's a perfect treatment for constipation because it brings more water into your poop, so it doesn't remain so dry and compacted. That's the nature of minerals. They stay in the gut, they don't get easily absorbed. On the other hand, amino acids get proactively absorbed. What does that mean? It means that your body is expending energy to actually take those amino acids and pull them into your circulation, into the cells lining the gut, and then into the circulation. So you are spending energy to proactively absorb the amino acid. And when you spend energy to do something proactively, what do you call it? You're not absorbing, you are adsorbing with a D. Amino acids get adsorbed because our body perceives them as extremely important. Why does our body perceive them as extremely important? Because in nature, we would be eating them in very small amounts. Scarcity is the rule of proteins in nature. In nature, we would have been eating a lot more plants and plant foods, and therefore we would have amino acids in them. But those amino acids, even if you have the entire constellation of them, all the essential amino acids are present in every green leafy vegetable, without exception. In 1 cup of kale, you get 5 grams of protein that appears in the form of amino acids. That's a lot. 1 cup. Those amino acids are complete. This protein is as complete as any protein you can imagine. Even though green leafy vegetables are not considered a good source of protein, by whom? By the cattle industry, by the dairy industry. They tell you that greens are insufficient. Ask the gorilla and the elephant if they are insufficient. Obviously they are complete proteins, but they occur as amino acids, not as complete large globular proteins. Where do we have complete large globular proteins which can maintain 100,000 amino acids in one chain that convolutes upon itself, that has numerous knots, such that we develop one globular entity that is so interconnected you cannot get anything in there, not even an enzyme can get in there. Those are the globular proteins we find in flesh, in dairy, and in nuts and seeds. Those proteins have a purpose, both in the animals, just like as they do in our own body, as well as in the nuts and seeds. That purpose is easily manifested when we manufacture our own enzymes, which are globular proteins, from what? From amino acids. So every globular protein that gets into your body has to be broken down into its constituent amino acids, or it would not be absorbed. So you are spending a lot of energy just breaking down proteins to the situation where they exist already in the green leafy vegetables and in the fruit and in other plant matter besides the seeds. Those amino acids are much easier for us to digest and to absorb because we don't have to break them down. But as soon as we have them in amino acids in the gut, in that form, that's when we spend the energy to absorb them, to adsorb them. And that's a very important distinction. Nature tells us how much we would have been exposed to in the past. Nature tells us that if we are going to spend that much energy on something, it's because in nature we would have had such a little amount of it that we would have had to make every amino acid count. And what does it tell us about minerals, by the way? What about minerals? Were they abundant in nature? What do you think? Yes or nay? Yes, they were abundant in nature. That's why we don't care about them physiologically. That's why we don't spend energy absorbing them. Because every food in nature, every green leafy vegetable, every plant that we ate has been rich with minerals, because those minerals were rich in the soil. And the plants that grow wild have deep roots, unlike the agricultural produce today. We would have had a lot of minerals, we would never have to worry about them. Plus, in nature, we would not be eating so many foods that make us deplete our mineral storage. When do you lose minerals? When you eat extremely high protein foods. You lose minerals because high protein foods burn in a way that leads to acid formation. Acetic acid, lactic acid, beta-hydroxybutyric acid, phosphoric acid, sulfuric acid. Those are all the acids that occur as a result of burning protein, digesting, metabolizing protein. All those acids build up in our tissues, and we have to leach minerals out of our main storage, the bones, the teeth. So we lose minerals as a result of high protein foods, but also our diet today includes many other things, like stimulants, coffee, chocolate, and other stimulants that cause our kidneys to open wide and allow too many minerals to be secreted in the urine. So our diet